So this is the second example that I'm going to be covering for this section. So when you see the question, you can clearly identify this with the brackets, right? So your y prime is separated with a term consisting of x and y, and you just have other term. So according to the general equation which we learned, this would be our m of xy, and if you remember, that was differentiated with respect to x. This term was n of xy, and that term was differentiated with respect to y. So since it was differentiated with respect to x, we have to differentiate it with respect to y now. Okay, but before doing that, what we have to do is we have to check if sigma yx and sigma xy are the same. Okay, so sigma yx is just going to be nx, and sigma xy is going to be my. So I'm going to do my first. So if I do my, y would become 1 and cos x would stay. So cos x plus, so this term would remain as it is because it deals with exponential. Now when I do nx, I would do this one. So sine becomes cos plus e to the y stays constant because we are differentiating x squared. So we get 2x e to the y minus 1 constant. So that goes. So we have my is equal to nx. So this condition is being satisfied, so we can proceed with the exact equations method which we followed. Okay, so we have to do this one now. So we have done this, so we're going to take this term which is nx, or we can also start off with this term xy. I guess I'll go with this term. So if it's xy, then I start off with x. So I'm going to take m, that's going to be y cos x plus 2x e raised to the power y, and this was sigma x for me. So I have to differentiate it with respect to x to get my psi function. So to get psi, I'm going to integrate this. So cos x becomes sin x and y stays as it is. So my first term is y sin x plus my e to the y stays, and I'll be integrating 2x, which would give me x squared. So I'll get x squared times e to the y. And over here, I'm going to go with a slightly different approach of not integrating the other term. So I'm going to include the constant over here itself. So I'm just adding a function with respect to y because I've integrated with respect to x here. So what I'm doing currently is I'm just going to partially differentiate this one with respect to y and just compare these two terms to find h of y. And that is again another way, or it's indirectly the same way to find psi of xy, which is ultimately what we need, right? So my psi y would become, this becomes 1. So I would have only sine x plus e to the y is what we're going to differentiate. So e to the y stays, and x squared, nothing would happen because it's a constant. So x squared times e to the y. So this term, there's no change, right? Plus h prime of y. We know that psi y is same as n. And we can compare these two terms because it's an exact equation, right? So when I compare these two, right, this term right here and this term right here, I can easily find out that my h prime of y is going to be -1. Okay, you can write this out and equate this out, and then you can also cancel the terms. Perfectly valid. So my h of y is going to be minus y. Okay, remember that h is a function of y only, so we are not going to add a function of x after this. So I know this, so I can directly frame my final answers of psi over here itself. So my psi would be, from here I can take y sine x plus x squared times e to the y. My h of y is minus y, and since I've partially differentiated with respect to x and y, I've left out the constants, so I'm adding back the constant in here, and this would be my final answer. So if you compare the previous example and this example, the method becomes slightly different just here, but the overall concept of arriving at the final answer is the same. You can do this method for the previous question as well. It's completely valid. And I would honestly prefer this method because you have only one integration to perform, whereas in the other method you'll have two integrations to perform. So this is the final answer.